everybody, this is a tutorial video on lesson 3-2, solving inequalities with addition or subtraction. This is algebra 1, and here we go. The cool thing about solving inequalities is you can use all of the tools that you know from solving equalities and apply them to these new problems. So let's think about something pretty simple at first. Let's just do x plus 3, and let's make that less than 7. Something like that. So we have to figure out all the values of x that if we add 3 to that value, it's still less than 7. I'm going to solve this the same way I would an equality. So I want to get that variable alone. I'm going to subtract 3 from each side. That's the subtraction property of equality. If you do the same thing to each side, it should still maintain its identity. So we've got x right there. I've still got the less than symbol. 7 minus 3 is 4. So as long as my x value is less than 4, this will work out. It could be a 2, it could be a 1, it could be a -5. Anything would work. To graph this then, I'm going to go ahead and put 4 on the number line. I'll put 1 up, 1 down, 3, 4, 5. This will be an open circle on the 4 because x can't equal 4, but it can be anything that's less than 4. So it could be 3.9, 3, 2, anything like that. All right, pretty simple, huh? Let's look at another example. So let's say that I've got a subtraction, maybe m minus 5, and we'll make that greater than or equal to I don't know, -2, something like that. All right, I'm going to solve this the same way I would solve an equation. I draw the wall. I want this m to be alone, so this time I'm going to add 5 to each side, the addition property of equality. This goes away. Bring down the m. Same symbol gets dropped down. -2 plus 5 is 3. So as long as my m value is greater than or equal to 3, this will work out. Again, let's go ahead and graph. This time I put 3 on the graph, 1 up, 1 down. This time it will be a closed circle because my solution does include the 3. M can be 3 for this to work. And I'm going to shade greater than. Not bad, huh? This works with fractions just fine. I know you love fractions. Everyone loves fractions, right? But we could have something like c plus 1/2 is greater than 5/6. Do the same steps. You just have to use your fraction rules. Get the variable alone. I'm going to minus 1/2 from each side. Just like that. That goes away. Bring down the c. Now the only issue here is that you can't subtract fractions that have different denominators. But I could very easily turn this 2 into a 6. All I have to do is multiply it by 3. Well, in a fraction, whatever you do to the bottom of the fraction, you have to do to the top, just like that. So this fraction becomes 3/6. Now I can go ahead and just subtract the top numbers. 5 minus 3 is 2/6. And I did the wrong symbol in the middle. Whoops. I need to drop down that greater than symbol. So c is greater than 2/6. Now if you wanted to simplify that, you'd say c is greater than 1/3. And you're like, Miss Croft, how in the world do we graph that? Easy. You just set up your graph with 1/3 on the graph. 1/3. The next thing up would be 2/3. The next thing up would be 3/3, which is really 1. If you subtract one of those thirds, you'll get 0. See? No big deal. You just got to count. This will be an open circle on the 1/3, and I'm going to go greater than. There you go. I got one more thing to show you. There's a little bit of trick to some of these once in a while. Once in a while, you're going to get an inequality where the variable's on the right-hand side. So something like this. How about we have 2 is less than 9 plus c. right? You see how that variable's over on this side. You can still solve it the same way. You still want to get that variable alone, so this time we're going to get rid of that 9. The 9 is positive, so I'm going to subtract 9 from each side. I'm going to bring down that c value, bring down the symbol. 2 minus 9 is negative 7. Now you might at first try to graph this, but the symbol is going to mess you up because you're going to think you need to shade less than, so this way, right? But remember, we're graphing what the c value is. And if you look at this, c is actually greater than negative 7, so you're going to shade the opposite way. My suggestion is, if you ever get an answer where your variable's over on the right-hand side, flip the whole thing around. So we get c is greater than negative 7. This is going to save you so many errors when you have to graph your answer because the symbol is going to match the way that you graph. So negative 7, 1 up would actually be negative 6, 1 down would be negative 8. And you're going to have an open circle on the negative 7 and you're shading greater than. So a good rule of thumb, when the variable ends up on the right side, flip your answer. That's a good rule of thumb to follow. All right, I hope this was helpful.